Good morning. Today we are going to discuss one chapter from 9th standard physics, that is force and laws of motion. In this chapter, first we will discuss about force and afterwards we will go to the laws of motion. We have three laws of motion, which is also called as Newton's laws of motion. First Newton's first law, Newton's second law and Newton's third law. So first we will go to the concept of force. So you already know we need force to do different work. When we apply a force on a particular object, that object moves. And there are so much applications of force. So in general, we can say when we apply force to an object, that object may move, or a object which is already under motion, we can apply a force to stop it. Or if the object is coming in a particular path, we can apply some force and we can change its path, or we can change the direction of path. So in totally we can say, by applying a force, we can change the velocity of the object. We can change the velocity of the object. Changing velocity of an object means we are giving acceleration to that one. So when an object is coming, if you apply force, we can change the velocity, that is we can increase the velocity, we can decrease the velocity, we can stop it, or already if it is stopped one, we can make it to start. All these things are coming under changing the velocity. So applying the force, we can change the velocity of an object. Similar to that one, if you have something like a spring, we can extend it by applying the force. That is, by applying a force, we can change the size of the object or shape of the object. You have a rod like this, a metal rod, you can bend it. When you bend it, by applying a force, its shape changes. So, in general, by applying the force, we can do three things. One is, we can change the velocity of the object, and second one is, we can change the shape of the object, and we can change the size of the object also. You have something which we can compress. You have a cylinder, in that one we have a gas. By applying a force, we can compress. So you can change the size of the object also. So we can see the effect of force like this when these three changes are happening. There are more changes also that we will study when we study in higher level. Now, when we apply a force on an object, we told that velocity changes or the object is moving. Now, for this type of force, we can classify this force into two types, the broad classification or the first type of classification. The force can be classified as balanced and unbalanced force. So we will discuss now what is balanced force and what is unbalanced force. Now you consider here we have an object like this. We have an object like this, that object is having a particular mass. We are applying a force on that. Whenever we are applying a force on the object, we can draw an arrow mark. This arrow mark indicates the force. Now you see here, this arrow mark is because it's a vector quantity. Force is a vector quantity. For example, 10 Newton force is applied here. What is this Newton? Newton is the SI unit of force. So how much is 1 Newton, that we will discuss later. First, in the beginning, you should know, for force we have an SI unit, that is called Newton. So 10 Newton of force we are applying on this object, so that this object will move in that way. Now you think another situation, you are applying, for another situation you have similar object only, you are applying a force of 10 Newton from this side and another 10 Newton from this side. So you can see that here this side also 10 Newton force is there, from the other side also we have 10 Newton force. So this object will not move. Now you see another situation. We have object like this. From all the sides we have, on the four sides we have same force. For example, 5 Newton here, 5 Newton here, and here also 5 Newton. Every side 5 Newton is there. This also, from the picture itself we can say, this will not move. This one will move. This will not move. Now another one more case we can discuss. Here you see, here we have 10 Newton this side and this side we have 5 Newton. So in this case also you know 10 Newton force you are applying from this side. That side you have only 5 Newton. So this will move here. Okay. So this is the two types of situations. So in one situation, for example, in this situation, what happens is we have so many forces. When you add all these forces, the net force is 0. Adding the force doesn't mean that this 5 plus 5 plus 5 like that. These are vector quantities. So if this is 5, from this side to this side it is minus 5. So this 5 and this 5, this is plus 5 if you take, this is minus 5. This is plus 5 if you take, this is minus 5. So the total force or the net force becomes 0. In this one only 10 Newton is there, net force is not 0. Here if you take, here we have 10 Newton, here you have 10 Newton. Net force is again 0. Here you see we have 10 Newton here, we have 5 Newton here. So this 10 and this is 5. The effective force will be in this direction 5 Newton. Now one more case if you want you can take. Here you have 10 Newton in this way. In the same direction you have another 5 Newton also. So total will be 15 in that case. So when the object is not moving, if you take the total, that is if you take the vector sum of all the forces, then the object is not moving. That case you can see the total force is 0. That's why it's not moving. So such case is called as a balanced force. So what is balanced force? If two or more forces are acting on a particular object, or the net force on a particular object is 0 and the object is not moving, such a situation is called as balanced force. That is, if two or more forces are acting on an object and the net force is 0 or the total force is 0, then such a situation is called as balanced force. Then what about unbalanced force? If one force or any number of forces is acting on an object and the net force is not 0, or if the net forces are not cancelling each other, in that situation we can call it as a unbalanced force. So first we discussed about the force, then we are discussing about types of force, that is balanced force and unbalanced force. So what is balanced force? If two or more forces are acting on an object and the net force or the total force is 0, then it is called as balanced force. If the net force is not 0, then it is called as unbalanced force. So from this one itself you will understand, when the total force is 0, the object will not accelerate, or it may be moving. Already it is moving, means it will move, that we will discuss later, but it will not accelerate or it will not move. For the beginning we will say it will not move. And what is unbalanced force? Unbalanced force means the net force is not 0. The object will accelerate, or if it is object at rest it may move, or there will be a change in the velocity. Such a force is called as unbalanced force. But in the case of balanced force, sometimes the shape changing, size changing will be there, pressing from both sides for a balloon. It is a balanced force. Still the shape will change. We are telling this balanced and unbalanced based on the movement only, not about the shape and size. If it is balanced also, sometimes the shape and size may change. But the speed or the velocity will change when the force is, when the force is unbalanced. So unbalanced force is more important for us. Now when we are studying in detail, unbalanced force is more important. Now we will move to the Newton's laws. In Newton's law, first we will discuss about the Newton's first law. This Newton's first law is also called as law of inertia. So generally the terms which we will use for the same thing is Newton's first law, or first law of motion, or Newton's first law of motion, or law of inertia, all are same. Okay, so in this Newton's first law, before going to the statement of Newton's first law, I will explain a particular situation. So you consider a smooth surface, which is a curved surface, something curved like this. It is very smooth. Very smooth means there is no friction in this one. Consider a surface like this. There is no friction, so it is very free to move. In such a situation, you think about a small ball or a marble which is kept at this point, and you are releasing this marble from here, so naturally this will come like this. So it will go up in this way. So already we discussed there is no friction here, so there is no energy wasted here. So what will happen? It will come to the same height. Okay, you may feel that this will not come to the same height, it will come little bit less than that one, because in the practical life you are seeing like this. It may not reach up to there, it will come up to here only. That is because of friction. Here we discussed there is no friction, this is super smooth. So that if you release from here, it will go up to the same height. It may not go or it cannot go above that one, because that much energy is not there for that one. How much energy is there here, that much only it can go here. It cannot go above that one. So it will come to the same height. So once if you release the marble from here, the marble can come to the same height. Now you think about another situation. I am just extending this one toward this side. That is the same thing. I am changing its shape little bit like this. And again I am releasing the marble from here. The marble will come here. So up to where the marble will go? Again the concept is there is no friction. If there is no friction, this marble will come to the same height here. The marble will reach up to the same height. So what is the purpose of our marble? Once it is coming down, it will go up to reaching to the same height. Because when it is reaching up to the same height only, it will come to the previous energy state that we will study later. So it will go to the same level. Now you think another situation. I am keeping it flat like this. Then what will happen? Once the marble is coming out, the marble will go like this. Up to where it is reaching to the same height, it will never reach to the same height. So what will happen? It will go on searching for the same height. So it will continuously move forever if there is no friction. So this concept is the main thing about the Newton's first law. That is, if an object is moving like this, it will continue its motion forever. That is, an object which is under motion will continue its motion ever. It will continue ever if you are not applying any external force. Unless an external force is acting on that one, it will continue the same path. Similarly, if you keep an object at a particular place, the object will be there only. If you apply any force, then only the object will move from there. So an object will continue its state of rest or of uniform motion unless compelled to change by an external force. That is Newton's first law. That is, an object will continue its state of rest or of uniform motion unless compelled by change by an external force. If an external force is not compelling it to change, it will continue the same state. So that is called as Newton's first law. Or basically we can say, if an object is moving, if there is no external force, the object will continue to move. And if the object is at rest, the object will be at rest if you are not applying any external force. That is Newton's first law. That is, the object will continue its state of rest or of uniform motion unless it is compelled by an external force to change, or unless an external force is applied on that one to change. Okay, that is Newton's first law, or it is also called as law of inertia. So we will think why we are calling it as law of inertia. Now see here, if you are in a particular situation, that is, you are keeping an object here. If you are not applying any force, this object will have a tendency to remain here itself. That is called as inertia. Some more better examples if you take, you will understand that. For example, you think that you are standing inside a moving bus. The bus is moving and you are holding on the top and you are standing like this. So if you are on the move, suddenly the bus stops. The driver is applying the brake. So what will happen? You will have a tendency to move front. That is, you were already moving. When you are already moving, you have a tendency to move front. So when the driver stops, your inertia will not allow you to stop. You have an inertia to move front, so that you are moving front. So that natural tendency to move front, that is called as inertia. Natural tendency of an object to continue its state of motion, that is called as motion of inertia. Sorry, inertia of motion. The natural tendency of an object to continue the state of motion is called as inertia of motion. Just the simplest example is the example which is about a person standing in the bus. You are standing in the bus and the bus is moving, you are also moving, so you have a tendency to move front. Once the bus stops, what will happen? You have the tendency to move front, so you will continue the movement. So that is the simplest example for inertia of motion. Now for inertia of rest also you can take so much example. Same case in the bus also you can take. You are standing in the bus and the bus is in the stopped situation. Bus is not at all moving. You are standing there. Quickly the bus moves front. You have a tendency to go back. Why? Because your tendency or your inertia was to stay there, not to go front. So inertia means it is a natural tendency of an object to continue the state of rest or of uniform motion. That is called as inertia. Once more, the natural tendency of an object to continue the state of rest or of uniform motion. That is called as inertia. So every object is having an inertia. Inertia of rest or inertia of motion. And if you think about the direction, there is a inertia of direction also. That is also a part of inertia of motion itself. Now see here, our Newton's law also telling the same thing. An object will continue the state of rest or of uniform motion unless compelled by an external force. So both says the same thing. Or we can say the Newton's first law also can be called as law of inertia. So inertia is related with the Newton's first law. So you should remember that one. Newton's first law is something which is related to inertia. Now if you take the case of inertia, if you take a object which is rolling around, you have a big stone which is rolling and coming. So why it is rolling and coming? Once somebody pushed means why it is again and again moving? It is having an inertia to move. So if you want to stop it, you have to apply so much force for that one. But if it is not a stone, if it is something like a small football which is coming, you can stop it easily. So from there you can see the inertia depends on the mass of the object also. So if the mass is very high, the inertia is high. If mass is small, inertia is small. Actually we have to tell in the opposite way. If inertia is high, we will call mass as high. So mass is a measure of inertia. That is very, very important. Mass is defined based on inertia. Mass is a measure of inertia. So generally 1 mark question and all will come. Mass is a measure of dash. So you should know mass is a measure of inertia. What is the meaning of that statement? If inertia is very high, mass of the object is very high. Or you can say opposite. If the mass is very high, it will have very high inertia. If the mass is very less, it will have less inertia. So mass is a measure of inertia. So what we discussed just now is about Newton's first law. That is, when object will continue its state of rest or uniform motion unless compelled by an external force. Okay. So and again we discussed about the inertia of rest and inertia of motion and examples also. There are so much other examples also. If you have a tree, in that one some leaves are there, almost dried leaf. When you shake the tree, the leaves will fall down. Why? Because the leaves are already having a tendency to stay there. When you are shaking, the branches are shaking, the leaf is not ready to move from there, so it will get detached. Same about the fruits also. Or if you take a mat, you have a mat, you are taking the mat and with a stick if you beat that, the dust will come out. Because the mat, on the mat, the dust is there. When you hit, the mat is moving. The dust is not ready to move. It's having an inertia to stay there. So that the dust will come out. So many examples. If you take the carom coil, you are keeping many coils one above other. When the carom striker is going and hitting the bottom one, that will move. The coils which is above that one, they have a tendency to stay there only. That's why they will stay there only. But if you slowly move, everything will move. But when you quickly move, what happens? Its inertia makes it to stay there only. So there are hundreds of examples for inertia. I am telling you to study each and every example because the question can be opposite. They will give the situation, why it is happening like this, what is the reason. Then you have to tell it's due to the inertia. So now we will move to the Newton's second law. Before going to the second law, you should know a new quantity which is called as momentum. So this momentum we will denote with the letter P. So we will discuss what is this momentum. You think a particular situation. You think about a glass which is little bit thick. And if you are taking a ball and throwing to this glass, the glass may not break. But if you throw with a very high speed, the glass will break. Now if you take a small bullet And if you take the bullet and throw, the glass may not break. But if you fire the bullet, it will break. So whether the glass will break or not, it depends on two quantity. One is the mass of the object which you are throwing or which you are projecting towards the wall. And second one is the speed or velocity of this one. So how much destruction it makes when something is going and hitting, how much impact it makes, that depends on two things. One is the velocity of the object, second one is mass. Or we can say there is a combined effect of mass and velocity which makes the impact when something is hitting. That combined effect, that is called as momentum. So this momentum contains both mass and velocity. Or we can say momentum is the product of mass and velocity. That is P is equal to m into v. Momentum is given by mass into velocity. The product of mass and velocity is called as momentum. So if something is having more momentum means when it hits, it can make more impact. So that's about momentum. So what will be the SI unit of momentum? The momentum is given by mass into velocity. So about mass, the SI unit is kilogram and velocity is meter per second. So for our momentum, the SI unit will be kilogram meter per second. Now why we are studying this momentum here? Because our second law is something related to momentum. Now we will go to the statement of the second law. The Newton's second law, already told, Newton's second law is related to momentum. The Newton's second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. So that is a statement. Once more, the second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Now we will discuss what is the meaning of this one. So already we discussed momentum is it is a product of mass and velocity. So what it says is the change in momentum first we have to take. For example, if the object is having an initial momentum P1, P1 is the initial momentum. Initial momentum means first momentum, that is mass into initial velocity mu. And then its momentum changes. It can be increasing or decreasing. So the new momentum I am writing P2, which is m into v. It is given by m into v. Now see here, what we already discussed here, the change in momentum, that is P2 minus P1, final momentum minus initial momentum, that is called as change in momentum. So change in momentum is equal to mv minus mu, or we can write that is m into v minus u. This is called as change in momentum. So change in momentum is given by m into v minus u, where m is the mass of the object, v is the final velocity and u is the initial velocity. Now the next point is rate of change of momentum. What is rate of change of momentum means? We have change in momentum, this one divided by time, that is called as rate of change of momentum. So what is that? I am writing rate of change of momentum is given by m into v minus u divided by t. m into v minus u divided by t. This is rate of change of momentum. So what our second law says, Newton's second law says that rate of change of momentum or rate in change of momentum is proportional to the force. So F is, or the force is proportional to mass into v minus u divided by t. Rate of change of momentum is proportional to the force. Now here you see, what is this v minus u by t? That is final velocity minus initial velocity by time. Final velocity minus initial velocity means it is change in velocity. Change in velocity by time. In the previous chapter we studied, that is called as acceleration. So what we can write? Force is proportional to mass into acceleration. F is proportional to mass into acceleration. Now what is the meaning of proportional? Proportional means when you change one side, the other side also will increase proportionally. For example, you are purchasing something, you are purchasing a biscuit packet. So how much biscuit packet you are purchasing and how much money you have to pay, that is proportional. So for one biscuit packet 10 rupees you are giving. For 2 means you are giving 20 rupees. For 8 means you are giving 80 rupees. So we can say our rate which you are giving is proportional to the number of biscuit packet you are purchasing. So how we can equate this one? Number of biscuit packet into 10 gives the amount. That is, when you remove the proportionality sign, you are multiplying with 10. So similarly, whenever you are removing the proportionality sign, you have to multiply with a constant. So see here, f is proportional to ma. If you remove this proportionality sign, then you have to put a constant there. In the biscuit case, we put how much? 10 as a constant. Here we don't know what is the constant. So what we will do? We will put it as k. F is equal to k into m into a. So we got a equation f is equal to k into m into a. So f is equal to k into m into a, where this k is a constant. Now we don't know what is the value of k, but up to this one, up to this calculation, we have not defined what is the SI unit of force. First I told you how the SI unit of force that we will discuss later. So here we are going to discuss how this SI unit of force is coming. For example, if mass of the object is 1 kilogram and acceleration is 1 meter per second square, if mass of the object is 1 kilogram and acceleration is 1 meter per second, then the force can be taken as 1 Newton. So this is 1, this is 1, this side also 1, then naturally k also should be 1 because left hand LHS and RHS should be same. So that's how we will take k as 1. So this will be little bit confusing for 9th standard children. Why this k becomes 1? We can simply say the SI unit of force, that is 1 Newton, is defined in such a way that k becomes 1. So what is the SI unit of force now? That is 1 Newton. What is 1 Newton now? If an object of mass 1 kilogram is accelerated by 1 meter per second square, then the force is 1 Newton. That's why this k becomes 1. If the k is 1, then what is our final equation? F is equal to ma. This is the equation which corresponds to Newton's second law. So this derivation step by step you have to study, and the final equation you will get numerical problems based on this one. F is equal to ma. Force is equal to mass into acceleration. So Newton's second law once more. Newton's second law, first we discussed about momentum. What is momentum? Momentum is the product of mass and velocity. Mass and velocity, if you multiply, we will get momentum, and SI unit of momentum will be kilogram meter per second. Now we have the Newton's second law. Newton's second law says that rate of change of momentum of an object is directly proportional to the applied unbalanced force in the direction of force. In the direction of force means this where force you are applying, same direction only, the acceleration also will be there. If you are pushing that side, acceleration will be in the same direction. That's why that in the direction of force, that's in the statement that is coming. That is the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. So that's about the statement. And from the statement, if you go derive like this, we will get this equation F is equal to ma. This is the final equation for second law of motion. Okay. So if you are not getting this one, once more this video you can see from the beginning. Again once more you can listen by step how it is coming. So that's about the second law of motion. Now we will think about some application of second law of motion. So as per second law of motion, this F is proportional to m v minus u by t, or we can say this force is inversely proportional to T. The meaning of that one is when force is more, time will be less, or opposite we can say when time is more, force will be less. So we have so many applications for this one, which we will not feel it as a second law, but actually that's happening. For example, the first thing which you know very well is in the case of cricket or any other game. If a cricket ball is falling from height, if you want to hold the ball, how normally you will hold? There are so many possibilities. You can hold your hand like this and you can hold it. And another possibility is you can hold the hand and along with the ball you can move the hand down. If you check any expert or anybody who is good in cricket, they will be moving the hand along with this one. So what is the advantage of this one? See here, when you hold this ball, the entire force by the ball is happening on or it's falling on your hand, or that impact is coming on your hand. Now you see here, how much force is there? That depends on the change in momentum. That initially that ball is having a momentum, finally it is stopped, so the momentum will be zero. So this change in momentum by time, that gives the force. Now for changing the momentum, you are starting to catch from here, slowly you are moving your hand down. So what will happen? It takes more time to catch this one. So the time increases. When the time increases, the force will be less. That's what happens. So when you are moving the hand along with the ball, what will happen? It will take more time to catch. When the time increases, as per Newton's second law, the rate of change of momentum reduces because time comes in the denominator. When the time increases, the force reduces. That's why a cricketer moves his hand along with the ball. This is one example. So many other examples are there. You think about you are jumping from a height of 4 meters. If you are jumping to a concrete floor, there is a chance of big injury because you are at a fraction of second you are stopping you. But you think about if there is a bed or water or sand, you are not stopping immediately. You are going little bit into the water or into the sand. So you takes little more time to stop. When the time takes more, the force will be less. That's why if you jump to a bed or jump to water, the injury is less than the injury which is caused when you are jumping to a concrete floor which is very strong. So all these things are related to our Newton's second law. So what you should remember is when the time is long, force is less. When the time is short, the force will be very high. You have a hammer and you have a nail. You will hit so fast. You are hitting so fast so that the impact time is very less so that it will go inside. So the force will be very high. There is another quantity called as impulse also that we will discuss later, that now it is not required. So these are coming as the applications of Newton's second law. Next one and the last one, that is Newton's third law. But you know this Newton's third law is the most famous among this one because it is a single word thing and it is used everywhere and it is used in most of the case with a wrong meaning also. It is not what Newton told you, the people are understanding. Okay. So the Newton's third law, it is so famous, it says that for every action there is an equal and opposite reaction. That is Newton's third law. For every action there is an equal and opposite reaction. Now here, what is action, what is reaction, that is very important. So whenever it is not something like you are telling something and there another person is telling you that your action, you are doing action, the other one is reaction. It's not like that. The action and reaction is happening at the same time. Action and reaction is happening at the same time, but they are acting on different objects. For example, I am pushing this wall toward that side and the wall is pushing me toward this side. That's why this wall is not moving. So if how much force I am pushing, how much force I am using, with the same force this wall or the board is pushing me this side. So it cancels each other. But every time it will not cancel each other. Here only I am telling it is cancelled. It doesn't mean that whenever you apply a force, it will cancel each other so that then how the objects moves. That also an issue. So if you take the Newton's first law, simplest example you can show using a spring balance like this. The spring balance, this is used for measuring the weight actually. Okay, it's used for measuring the weight. Weight is actually a force, so here the values will be written in Newton also. Now what happens is, if I am using such two spring balance like this, and if I pull like this both will show the same reading. If you are able to see, you can see that one. If this one shows 250 gram, this one also will show 250 gram. So what is the actually this side I am not moving, I am pulling only this side, but you see both are extending. So how much force I am using on this one for pulling, same force is applicable for this one also. So I am pulling this one only. So if this is the action, as a reaction this one is coming here. Okay, so for every action there is a equal and opposite reaction. So don't think these two will cancel each other. Why it is not cancelling each other in the normal case? For example, a simplest example people used to tell. You think about a bullock cart. The bull is pulling the cart. If the cart is pulling the bull also, it will be equal and opposite. It will not run at all. That will not happen actually. Because when you are pulling the cart, actually what the bull is doing, bull is pulling the cart. That's what we are seeing. But actually the bull is pressing its feet to the ground and applying a force towards backside. Then only the bull can move front. So actually when the bull is applying a force towards backside, as a reaction the bull is moving front. And you don't consider that the force by the bull, it is pulling the cart here. The cart is a separate thing. Now you see here again, if you take the cart, the wheel of the cart is moving like this. The bottom of the cart is pushing back so that the cart is moving front. So in the bull and cart, you don't take bull and cart as a separate thing so that one is action, another is reaction. It is a total system. The bull and cart both are applying the force on the ground so that the cart and the bull together it moves front. It will not cancel each other. I think it's clear. So the statement is, for every action there is an equal and opposite reaction. We can write that one as equation also. If you have two objects A and B, then we can write FAB. What is FAB means? FAB means force on A due to B. FAB is equal to minus FBA. That is FAB. That is force on A due to B is equal to minus of force on B due to A. That is they are equal and opposite. They are equal and opposite. So for every action there is an equal and opposite reaction. Very important point. They are acting on different objects or different bodies. That's why they will not cancel each other. Now we have to go some more about this equation. That is from this one we will get some more data about the same concept. Okay, and after that we will go for the examples. Now you see here, this FAB, if you have two objects A and B, what is FAB? Force on A due to B. So this can be written as from the Newton's second law, rate of change of momentum, or MA. So mass of MA means mass of the object into B minus U, B of A, U of A divided by T. Like this we can write. This is the force acting on A due to B. Similarly, force acting on B due to A can be written as MB into VB minus UB divided by T. There is no need of writing T of A, TB, because time is common. The interaction time, the hitting time is common for both. Okay, so the both are going and hitting same time. This situation is like this. You have one ball object here. This is with the MA, which is going with a velocity UA, and another object which is having mass B, MB with UB. These two are undergoing collision. MA, MB. After collision, again it is going with BA and VB. But we don't know which is the direction. After collision, whether they will go that side or this side, that we don't know. That depends on the collision. Now we think that all are going that side only. Sometimes one is coming this side also, that possibility also is there. That we will discuss later. So we have this equation. Now what it says, FAB is equal to minus FBA. So this one and this one we can write equate MA into VA minus UA divided by T is equal to MB into VB minus UB divided by T. Initially, sir, this T and T you can cancel. Then what is remaining? MA VA minus MA UA is equal to MB VB minus MB UB. So all this one if you take to same side. So here totally a minus sign was there. Here one minus sign is there. Here one minus sign is there. So if you remove this minus sign, here it will become plus. Now, if you take all the initial value here, we can write here MA UA plus MB UB is equal to MA VA plus MB VB. Okay, now once more you see this equation. What is MA UA means? Mass of the object A into initial velocity of object A. That is this one says it is the initial momentum of A. This is initial momentum of B. So what will be this total thing? This is initial momentum of first one and second one, or total initial momentum. What is this one? MA VA final momentum of A. This is final momentum of B. So what is this total one? That says that this is the final momentum of the total final momentum. So it says that initial momentum and final momentum is same. That is, how much was the total momentum of the object before collision? That will be same as the momentum after collision. Or total momentum before collision is equal to total momentum after collision. So this is our most important equation. Momentum before collision is equal to momentum after collision. This is very important. From second law of motion, we are getting this one. Momentum before collision is equal to momentum after collision. So based on this one, you will have to do so much numerical problems. That is, initial momentum is equal to final momentum. Total initial momentum is equal to total final momentum. Now one more thing is that in some case what happens is initially nothing was moving. In that case initial momentum will be 0. For example, you think about a gun. In the gun we have bullet, gun, everything is there. When you shoot, what will happen? The bullet will go front. So before shooting the total momentum is 0. Once you are shooting, what happens? Afterwards also the momentum should be same, because initial momentum was 0. So what momentum the bullet is going front, same momentum the gun will come back. So when the gun is heavy, as the gun is heavy, the speed will be less, because mass into velocity gives the momentum. Bullet is very small, so it will go with very high speed, and gun is very heavy, so it will come back with a less velocity. That coming back, that is called as recoil. So recoiling of gun is a very important example of this conservation of momentum. This is called as conservation of momentum. That is, initial momentum is equal to final momentum. That is called as conservation of momentum. So here this equation gives or explains the conservation of momentum. This step by step you can see here, or once more if you see your textbook you will understand. So this one is called as conservation of momentum. That is, initial momentum or the momentum before collision is same as the momentum after collision. And the simplest example is in the case of a gun. That is, before firing the total momentum is 0. Once if you fire, what will happen? The bullet is going with a momentum. With the same momentum, this gun will be coming back. Any other examples also you can take. So if you take the other case, all these things can be taken as the examples of third law of motion. In the case of rocket, you have a rocket which is moving up like this, means there will be some fuel and burning, and afterwards this smoke will be coming down. So how much momentum is there for this one? So because of this momentum it is going up. So this is working based on the Newton's third law. So every action there is an equal and opposite reaction. That's why it's going up. So the total momentum remains same. How much is coming down? So that much should go up. Then only the momentum remains same. So many other examples for Newton's third law. And simplest example you can say another thing. If a boat is there, you are standing on the boat, you are jumping to the shore from the boat. Then what will happen? The boat will move back. That is another example. Like that you have so many examples. So up to now what we done is, we just done the theory part of this chapter. We discussed about entire thing in the chapter, but just the theory. Now as a student what you have to do? From the textbook all the derivations you have to do, and you have to practice questions based on this one. In another class we will explain what are the questions, how to do numerical problems, all those things we will explain in another class. First you study this theory part, so that when the question comes, you know the theory means it will be very easy for you. So today we will wind up by studying this theory. So what are the things we studied today? Completely the things what we studied is, first we started from force, and afterwards we discussed what is balanced force and what is unbalanced force. After the balanced force and unbalanced force, then we came to Newton's first law. There we discussed what is Newton's first law, what is inertia of rest, what is inertia of motion, and after that after all this inertia thing, we discussed mass is a measure of inertia. Then before going to the second law, we discussed what is momentum. Momentum is a product of mass and velocity. Then second law of motion, the statement of second law of motion also we discussed. Then from the second law we done F is equal to ma, that equation also we done. And there we defined 1 Newton. What is 1 Newton? That also we discussed there. After this 1 Newton, then we came to the Newton's third law. For every action there is equal and opposite reaction. From that one we came to this equation, or this is called as a conservation of momentum. And after conservation of momentum we discussed the example of this one, Newton's third law. Previously also examples for Newton's first law, second law also we discussed about the inertia of moving in the bus and all for the first law, and catching the ball for the second law. So once you recap everything and study this one, then we will move to the numerical problems and questions based on this one. Thank you. We'll find up now. Bye.